So today we'll be doing the door simulator. So in order to do that, we can go through simulations and door simulator right here. Right, so this is my door simulator, and basically what it does is that once I press the open button, the door should open, and once I have the press the close button, the door should start closing. At any given point, if I want this door to be stopped, I can press the stop button, and I'll explain each and every component. So I have my digital inputs over here, which is my stop, close, open, close, and stop buttons. Open and close buttons are normally open buttons, so they control the door's motion. So if I press the open button, the door will start opening, and if I press the close button, if the door is already open, it starts closing it. And the stop button right here is a normally close button. So when we press it, it opens the circuit, therefore cutting the power and halting the door's movement immediately, whether it's opening or closing. Similarly, we also have some more digital inputs, which are these two limit switches over here. So these two switches are mechanical switches that activate when anything is pressing against it. So for example, over here, which is our SLS2, which is our down limit switch, turns on when the door is fully closed, and this turns on when the door is fully open. So we can use these two limit switches to decide if the door is completely open or closed. And we also have our digital output, which is our motor control. So these two motors are hooked up in a contractors where each motor decides the direction. So when the motor up is energized, the door opens and the motor runs forward, and when the motor down is energized in the other side of the contractor, the door closes and the motor runs in reverse. That's why the door closes. So one thing to note is that these two motors should never be activated at the same time because this will cause a short circuit. So we need to have an interlocking feature to ensure that these two motors are not running at the same time. We have another digital output, which is our indicator lights over here, which will indicate if the door is open, it is indicated by this light. If the door is shut, it is indicated by this light. And at any given point, the door is indicated by this ajar light right here. So these are like a visual feedback for the operation of the door. So let's start the ladder logic for this problem. I'm going to start with something very basic, which means that once I press the open button, the door will open, and once I press the close button, the door will start closing, and include the stop logic as well. So I'm just going to do that for the open one. So I'll have a normally open contact, which is going to be my digital input, which is open right here. I'll rename this to be open switch, and this will turn on after I press this button. It should activate my motor up, which is a output over here, and I'll drag that address over there and rename this to be motor up. And now that we have that, I want to have a latching contact, so I'll include a rung over here. I'll drag the open switch over here, as well as another normally open contact, and drag the motor up direction over here. So I want to have this motor running until and unless this limit switch is high, which means that the end of the garage door has reached this location over here. So I will have a normally open limit switch over here, normally open contact, and I will copy the address of the limit switch, and I'll rename this to be limit up. And I also want to stop working if I press the stop button. So I'll have another normally open contact and copy the address of the stop button right there, and have that as stop switch. Alright, so essentially what happens is once I press this open button, it will, because the limit up is not turned on yet, and the stop switch has not been activated yet, it will keep on going until the motor up is energized, and once it's energized, it keeps on doing that, energizing it. So let's see this in action. Download the code and run it. So as you can see, once I press the open button, oh, that's a jarring noise. Okay, so once I press the open button, the garage door opens, and it continues to stay open. Oh, if I want, I can stop it. So that stops the program. And if I want to, I can continue having it open. And it opens until it hits this limit switch, and that halts the program. So I'm going to do the same logic, but for the close button this time. So have it normally open contact. I'll drag the address of the close switch right here. Rename this to be close switch. And once that happens, I want to turn on the motor down. So this time my output would be motor down. And I'll rename this to be motor down. And I once again want a rung in here to make sure it's a latching contact. So I will drag that over here. And I will have a normally open contact over here for my stop switch. Okay. Now, this one is a little bit trickier because as you can see, the limit switch is on right now. So this limit switch will only turn off basically once this whole shutter is all the way down. So instead of having a normally open contact, we're going to have a normally closed contact. So I will drag my limit switch over here, and I'll change this to be limit lower. Okay. And this will essentially stop powering the motor right over here. So let's see this in action. Download the code and run it. So as you can see, I can start closing it, and I can also press the stop button for it to stop and continue closing it, and again press the stop button for the shutter to stop, and again continue closing it until, bam, right here, this cuts off the power supply. So that's about it for having the basics of the setup. Alright, so this does have some limitation. This ladder code does have some limitation, and I'll show you what it is. So when I press the open, the garage door opens, but once I press the close button, yes, that happens. So this happens because since it's the same contactor is used for motor up and down, this causes a short circuit, therefore the motor fries up. And in order to avoid this or eliminate this, we need to add an interlocking feature between these two motors. So that means that the motor up will only run if and only if the motor down is not running. And the same case, vice versa. So motor down will only run if and only if the motor up is not running, which prevents all that frying up case. So let's clean this up. And it's quite simple. We just have a normally close contact right here that will say that if the motor down is not running, then only turn the motor up. And the same thing over here, if the motor up is not running, then only turn on the motor down. So this solves that um, fire and short circuit case, and we can see that right here when I run the program. And once I press the open button, even though I'm trying to press the close button, it doesn't allow me to do that. And there you go. That's the case for it. So now we will be working with the digital outputs indicator lights over here, which will indicate the status of the door. So if we want to display that the door is open, we want a normally closed contact over here because, just give me one second. Okay, so when the door is fully open, this limit switch turns on. So we want a normally closed contact. So this contact over here will open so that it will power up my lamp, which would be um, the open lamp right here. And I'll just drag the limit up right here. And I'll name this as open. Now, as you can see right now, this limit switch is already open. So over here, in order to see if the door is closed, we want this limit switch to be basically have the opposite effect. So for that reason, we will have a normally open contact. And I will drag the limit lower over here, and I will have my close, my shut output right here. Now change this to be shut. Essentially, once the door is fully closed, the lower limit activates, and then it turns off, and then we need an opposite reaction to turn on the lamp. And for the ajar, we want the inverse of these two situations. So we are going to have a normally open as well as a normally closed contact. And over here, instead of having limit up as normally closed, we will have limit lower as normally closed and normally up as our open contact. So this creates an inverse of these two situations, which means that if it's not this or this, then it turns on my ajar lamp over here. And I'll just put that in there right here. And I'll edit this to be ajar. And let's see this in action. So I'll download my code and I'll run it. So right now you can already see that my ajar is turned on. So I can continue to open it. I can also stop it, continue to open it until this limit switch activates and this solution is fulfilled and this condition is fulfilled and it turns on the open lamp. The same thing with close. While I'm closing, I can press the stop button and I can close. And also, in order to ensure that it's not short circuiting, I can also press on the open and you can see that it does nothing. And I can also press on the stop button and I can continue closing it until this limit switch activates, which is right here, and then it shuts the program and it shows that the door has been shut. So that's all for today. Thank you.